Thank you so much. Thank you everyone for joining. It's great to have you back. This is the first colloquium session for the spring series at EMO 2026. We're super excited to have Rachel Franklin. The Urban Data Science Working Group is going to introduce the talk in a minute. I just want to highlight that this is a colloquium series, and so this is the first talk, but we have two other upcoming talks. If you're interested in joining, make sure to check out the website. I also want to highlight that the call for papers for the EMO conference is open now. The deadline for the abstract submission is May 1st, if I'm not mistaken. With that, I'll just pass the moderating role to Gabriel from the Urban Data Science Working Group. Thank you so much for joining.
Yeah, thanks so much, Felipe, and welcome everyone. Thank you so much for joining. My name is Gabriel. I am one of the co-organizers of the Urban Data Working Group. I'm here alongside Matt, who's here, Jenna, who should be joining, who's just connecting right now. So we work on discussing how spatial data science tools can be used to improve equitable city planning and improve urban life. So we're very excited to kickstart the EMO colloquium this semester, and Rachel Franklin has agreed to join and give us a talk today. She'll be talking to us about spatial inequality in the smart city. She is the executive director of the Center for Geographic Analysis at Harvard University and adjunct professor of practice at Brown University. Her primary research focus is spatial inequality, especially the interplay between spatial analytics and demographic change. And Rachel likes new data, old data, big data, and little data, especially when this data is spatial and especially when it's deployed in response to new, old, big, and small societal changes, which I thought it was a great bio for a speaker to be here. She also really values interdisciplinary research, as many of us here at EMO do. And she is one of the co-hosts of a really great podcast. If you're looking for something to listen on Spotify, it's actually an award-winning podcast as of recently by the Association of American Geographers. It's a podcast called GLAD, Geography, Life, and Data, where they discuss everything geography, life, and data, alongside Danya Ribas-Bell and Levi John Wolf. So I'll pass it on to Rachel. If I said anything egregiously wrong, please correct me. And thank you again for being here to talk. And yeah, hope everyone enjoys.
Well, thank you so much for having me. You would think that I would be used after 6 years or whatever of Zoom to navigating a virtual talk, but I can't see any of you, so I can't tell if I'm boring you or if I'm confusing anyone. So I'm just going to assume that everything's okay unless somebody hollers at me. But this is a project that lasted in the end, partly because of COVID, about 5 years. So it has lots of moving parts. And this sort of is a talk that tries to pull everything together from this project. Yeah. And so with that, let's see if I can go ahead and get started. All right. So the sort of overarching goal of the project was to think about emerging technologies. And in particular, we were interested in air quality sensors and how they're placed within the urban fabric and how that sort of intersects with where people are located, what kinds of people are where. And so if you think about the sort of two parts, right, the sensors and then the people, those sort of come together to either make inequalities worse or to create them or simply to reproduce them as a new form of technology. And so this was what we were interested in exploring and hopefully coming up with some tools to do better in the future. And so we were especially interested in how to measure sensor coverage. Like if you know that there are air quality sensors in the city, how do you come up with estimates of like how many people or how many of which group are covered by those sensors, what it would mean to fall into a sensor desert, what kinds of people are in gaps, and then how to think about equitable decision making. So this is going to be a talk in 3 parts. One is to hopefully persuade you that you should care about sensors and sensor networks. Although I do think that we're moving fast enough that I will be kind of curious in even like 2 or 3 years if sensors and sort of thinking about point-based data collection is even the way that we're thinking anymore about gathering information about cities, but maybe that's for discussion. But so why you should care about sensor networks, how we can conceptualize and measure coverage, and then how to think about the equitable decision-making piece. Okay, so sensors are everywhere. And I find myself after all of these years, I just moved to Cambridge, Massachusetts about a year ago, and I'll be walking down the street and I'll look up and I'll think, there's a sensor. So you do get kind of trained to realize that they're everywhere, right? And so there are lots of urban projects that have thought about where to place sensors in cities. And sort of at the beginning of the project, we were thinking, is there just one way to do this? Do all cities decide we're going to need to have sensors? And I care about air quality, but there are noise sensors, there are footfall sensors. There are all kinds of sensors that are placed to gather data about cities and people in cities. And we were sort of curious, like, does everywhere start from the same starting place of like, okay, we want some sensors, where should we put them? And it turns out that this is done in lots of different ways. And that a lot of times these sort of smart city projects at the urban scale, there's a lot of, well, on the one hand, there's a lot of sort of city marketing that goes into it. And in the other, because dealing with those data is so complex, a lot of the actual work that goes into smart city infrastructures is about the compute, right? So there's how you handle the real-time information coming in. So the sort of the edge computing that has to happen, how you're going to process that information, how you're going to make it available to users, what you're going to do with it, how you calibrate. And all of that is really complex. So a lot of time gets spent on that piece of it. And it turns out that relatively little time gets spent thinking about where you were placing the sensors in the first place. Although this does vary from city to city. But that was the thing that sort of grabbed our attention to start with. And the other was that at the time, I had just moved to Newcastle in the north of England, which has a very large sort of ongoing project that's called the Urban Observatory that has lots of different kinds of sensors placed around the city. And so when I first wrote the proposal, the idea was that I would be working with civil engineers and geospatial engineers and geographers to sort of think about how to estimate coverage. And then as we sort of started digging in to the Urban Observatory with these civil engineers, and you'll see in a moment, I started thinking, wow, this is really interesting choices that you've made about where you put these sensors in the first place. So apologize to anyone who's an engineer, but very, very quickly, one of the interesting things about this project was that there was so much divergence between what the engineers were interested in and what we were interested in, that we didn't end up having as much interaction as we thought there would be at the beginning. And this turned into a little bit more of sort of a real sort of geography, spatial demography project. Okay, so this is the Urban Observatory. It's the UK's densest air quality monitoring network. So they were great partners to start with because, well, they're on the ground actually collecting data and actually arguing for its use in urban policymakers. And our argument is that these sort of smart city sensors, air quality sensors, are just yet another form of infrastructure, right? So if we think about sort of the basic physical infrastructure of a city like roads or water or power, you could think of sensor networks as just yet another iteration, 21st century iteration of urban infrastructure, right? And infrastructure has always come with challenges. It's always been expensive. It's always required a lot of money and time and attention in order to keep it maintained and functioning. It requires a lot of engineering and planning expertise in order to make sure that it's serving everyone. Service levels tend to vary, and right, whether we're talking about like road connectivity or electricity connectivity and access, equity has always been an issue. So thinking about air quality sensors or sensor networks in smart cities, when we argue about the inequities of these structures, it's not so different necessarily from any other kind of infrastructure that's ever come before, which I think is a really important thing to keep in mind. It's not like we have these new forms of technology that come in and for the first time ever, we're struck with how inequities are perpetuated. This has always been with us. All right. So we get new forms of infrastructure and same equity challenges, but we have lots of other challenges that are sort of happening at the same time, right? A lot of discussion about digital internet divides, the inequities that happen when we talk about energy transitions and net zero, sort of who's going to be left behind, who gets to make that transition, and then smart city infrastructures. So we can think about infrastructure, then we can think about all of these other kinds of challenges that are hitting cities at the same time. And I think there are a lot more that we could talk about too. Okay. And lots of people have written about new technologies, right? From the fact that they do tend to polarize and divide, to the fact that smart cities privilege some places and people over other places and people, to the fact that some voices are left unheard or rendered invisible. And that when we talk about smart city data and algorithms, there's no real separating those from urban inequalities. They work together. And to me, that's less of a, I mean, I don't see this as sort of like an insurmountable challenge. I see it more as like this is an interesting puzzle to try and fix. If we know that we have these challenges in the way we tend to build things, how do we try and force ourselves as human beings to do better? And so our case study is Newcastle upon Tyne, for those who've never been there. And an interesting thing about Newcastle, so it's sort of this polygon, there's a river in the white. I'm waving my hands in front of my screen, I don't know if you can see. But that whole polygon up there is all Newcastle. And the red dots are the urban observatory air quality sensors. And so at first glance, they're clearly not sort of uniformly distributed. You could maybe make an argument based on population density that this isn't such bad coverage, but as you'll see, it's not fantastic, and it doesn't look fantastic at the outset. If you look at the sort of neighborhood scale, these LSOAs are sort of the equivalent of like census tracts or block groups in the US setting. You'll see that most of the area of the city is definitely not covered by an air quality sensor, regardless of what's happening with the people. So at first glance, without embarking in sort of a 5-year research project, you might say some decisions were made along the way that might be justifiable, but clearly it doesn't look like equitable or uniform, more uniform distribution of air quality sensors was the goal of the urban observatory. If you then look at neighborhood deprivation, so in England, they have this IMD, so this index of multiple deprivation that captures like lots of different dimensions of inequality. Neighborhoods are then ranked based on this inequality. And so what you see here for Newcastle, sort of slightly larger geographies than LSOAs, but what you see is this index of multiple deprivation. Those reddest neighborhoods are among the most deprived in all of England. So you can see they're ranked there, like 45th for Walker out of all of the neighborhoods in England. These neighborhoods that are highlighted here in red are among the most deprived, not only in the city, but in the country. They also happen to have major roads that pass through them, like highways, and they don't have any air quality sensor at all. So this was sort of like, I think like the first paper that we worked on this project. I was just sort of arguing that if you think about it from sort of like both an exposure and a sort of source perspective, then some of these arguments about where air quality sensors are being placed don't really hold water, right? Because if you've got a major road in terms of emissions, this would be something that you would want to be monitoring normally. And if you know that you have vulnerable populations, you kind of want to know how exposed they are to poor air quality. So in the face of it, Newcastle wasn't doing fantastic. Right. Okay. So thinking about how we conceptualize coverage, right? This is a kind of it is kind of tricky because for one thing, when we talk about surveillance technologies, and I've given, especially this early part of the talk, to so many different audiences. And one of the questions that I used to get so often at the beginning that I now have this slide was, actually, you're talking about sensor deserts, Rachel, and people who fall into gaps as being missed, but maybe it's a privilege not to be counted, right? Because air quality sensors are a form of surveillance. So then we had to kind of think about like these sensors, it's true, they are surveilling something, but how do we distinguish between the kinds of technologies that are surveilling people? And I think footfall or noise are examples of those kinds of things versus stuff that's affecting people, like air quality sensors, right? And then you have the stuff in the middle where, noise can both be policed in terms of, people or communities that we think are too loud, but also we know that noise has adverse health effects, right? So there are good reasons why we would want to be able to monitor noise. Similarly for traffic. And so I think depending on what kind of sensor you're looking at, there's an argument for sort of the privilege of falling into a gap versus like the inequities of falling into a gap. And with air quality sensors, I think I find myself sort of squarely in the corner of we need to be measuring air quality because we know that it affects people's health, and we know that certain groups of people are more likely to be unmonitored in terms of health, in terms of air quality, and they deserve to be counted. All right, and so there are different ways of thinking about what the purpose of sensors would be, right? So an argument, this is one of the first issues that we had in sort of discussing with the engineers, was that from their perspective, really air quality sensors should be placed at the point of source of hazard. So what you're really doing is monitoring the hazards, right? which is different from monitoring exposure or vulnerability, right? Because the emissions happen in one place, and then you have people who are sort of static or they're kind of moving around in the city and they come in contact with poor air quality, for example. And so you might want to make sure that you have the air quality sensors in places where you're ensuring that you're covering the populations who are disproportionately at risk, right? The way we measure uh, the way we measure coverage, though, is going to depend on what the purpose of the network was in the first place. And here to go back to like, why do cities call themselves smart in the first place? Why would they think about air quality sensors? And of course, one of the first answers is that they want to know how good the air quality is and where it's poor, and if they're meeting, national level regulations about air quality. But really, for a lot of cities, it was about marketing. For politicians, it can be about representation, for ensuring that you're telling your constituents that you care about what their neighborhoods are like, that you care about neighborhood quality, right? Or it could just be about modeling, about generating a surface of air quality, so that you can get some sense of like where air quality is better and where it's worse. And so depending on how you're measuring coverage, if you're going for representation, then you don't necessarily care about like what the footprint of a sensor is, like it's sort of capture shed of like what kind of area is it providing good measurements for. What you really want is to be able to say your neighborhood has X number of air quality sensors, right? It's about representation. And so coverage would be simply being a place that has a sensor. You could also, though, think about trying to measure coverage in terms of catchment areas or footprints of sensors, in which case anywhere that falls outside of those catchment areas is going to be a sensor desert. So this is sort of like, the first iterations of when we started talking about food deserts way back when. You fall outside the area, you're inside a desert. But you can also think about sort of a technical way of estimating gaps or deserts, which is that if the sensors are really being used to generate a surface, right? So, and when we say surface, that means that every single location in the city is going to get an estimate of its air quality. The input is point-based, right? But the models then generate surfaces. Then for me, the issue becomes whether or not people or who or how many people are living in parts of the city where your uncertainty band is a lot larger. Like you're pretty sure that the air quality is okay, but your confidence isn't super high. I would think of that as potentially being in a desert. Some people get to live in places where we're really sure what their air quality is, and for other people, we're just kind of guessing. Okay. So for us, sensor deserts are parts of the city that are not covered or represented by sensors. They're places for which we're not producing knowledge about air quality, or they're places where the modeling uncertainty is higher. And so what we do, this is the only slide that has a little bit of the methods in it, but we kind of need it to try and get at how we're going to estimate coverage. So we estimate coverage in two different ways. And this is sort of like the middle part of the talk. And I should say, I didn't put any references for papers, but these days it's pretty easy to figure out what these papers are. This paper was in the annals of the AAG. It's about sort of equity in network creation. And we do this two ways. So on the one hand, and we have really good tools for this. So none of these are new algorithms, right? This is like almost like off the shelf, like what we know how to do as geographers today or 3 years ago. If you have a group of people, for example, kids, and you want to maximize their coverage, you can do this based on that one, you have X number of sensors that you want to locate across the city, you maximize coverage of that group. The issue is going to be that the kids are not in the same place as other vulnerable populations, right? So you can also use this sort of multi-objective genetic algorithm, which is what we do, to generate lots and lots and lots of networks and then look at how they perform across a set of different groups. So you can sort of pick and choose the network that's going to work best for you in terms of coverage, because there are always going to be trade-offs, right? You can, if you maximize coverage of kids, you're going to lose some other groups of people because they're not living in the parts of the city where the kids are. And the really interesting thing to me about the generating lots and lots of networks is that you're generating networks that have variable coverage across different groups. But on the ground, those networks are also going to move around. So this sort of leads into sort of thinking about decision support, because for local planners, especially in a UK case where they, under austerity, they don't have a lot of expertise to sort of figure out where the best place to put sensors is. Being able to see on the map and to visualize the trade-offs is actually a really helpful thing you can do just to render it visible to them that these trade-offs actually do exist. And that really helps in communicating to residents why a sensor here and not somewhere else. Okay, so you've got these two different algorithms. You then have to think about what the coverage is going to be for a sensor. And when we started with the project, our idea was that we were going to be able to think about different kinds of catchment areas for different kinds of sensors. But it turns out that that's just really complicated because sensor technologies are changing. The sort of what it says on the packaging in terms of their coverage it all depends on sort of where they're placed in the city and what the built environment looks like, what the weather is like. So this theta that's sort of highlighted in blue in the middle of the slide is capturing sort of an estimated decay or coverage for a particular sensor. And we do it for sort of a short distance that would replicate the idea of representation. It just needs to be in your neighborhood or not in your neighborhood versus something a little bit wider. And for us, we place the sensors at the centroid of the output area, which is the smallest sort of census geographic unit in England. Yeah, it would have been nicer to do something else. And if this comes up in the discussion, I'm happy to talk about this. But it turns out like the places that you're allowed to put the sensors drives a lot of the variation that we observe in where sensors are. And I don't know if it's different in the US, but I imagine it's pretty similar. Okay, so we're going to maximize coverage one group at a time. And so this is for the population that's over 65. And you've just got these four little maps. But at the top, this is for sort of the smaller theta. So this is at 100 meters, so not very much coverage at all, right? And so what you see at the top is that with 55 sensors, sort of in that top right corner, you're not going to cover much of the population at all. It's like 20% of the population. And that's because the coverage of the sensors is really small and you don't have so many sensors, right? So if money were no object, you could place lots and lots and lots and lots of sensors around the city. At the bottom, though, if we sort of extend that coverage and we say, okay, like at half a kilometer, if 500 meters, we're going to say you're covered by your closest air quality sensor, we get to about half of the over 65 population. In contrast, so just to take like sort of the other end of the continuum, if we look at the place of work population, and so it does exactly the same thing, what you see in that bottom right-hand corner with 55 sensors is that we can get to almost 80% of the place of work population. So you can get much better coverage, but you get a much more clustered geography of sensors. So what happens is something that's not so surprising, which is that if you think about sort of place of residence population, like over 65 population, where they're sort of scattered, right? They're not all living in one location. So it's harder to cover a whole bunch of them without a lot of sensors, whereas place of work is very clustered. People concentrate in very few buildings. So you could think about schools for kids versus residence for kids. But the key thing here for us is that the geographies are just really, really different. So this illustrates sort of like the starkest trade-off. Like if you want to cover the population over 65, you're having to trade off on place of work population because those geographies are just really different. And in terms of number of sensors, it sort of increases really sharply in terms of coverage and then starts to level off after about 50 or 60 sensors. So there is a point at which that marginal gain from additional sensor in terms of coverage of the population, it's not giving you a lot of bang for your buck. But for the worker population, for any number of sensors, you're just able to cover a lot more of them because they're concentrated in space, right? And so if we think about where people are located in Newcastle, so these are maps of Newcastle, the total for the sort of total population, that map labeled A, you can see that sort of the population sort of there's more density around the city center, and then it sort of falls off pretty sharply. Kids have a slightly different geography, and then that older population is even sort of more widespread, sort of like an outer area of the city, which would hold for a lot of cities, right? And the key here is just that people sort across space, different kinds of neighborhoods serve different kinds of populations of people. If we're thinking about more than one kind of vulnerability, it's going to be really hard with this sort of, maximizing coverage of one group to not accidentally leave other groups behind. And then that bottom right, you can see the the place of work population is just really, really concentrated in the city center. So very different geography. And this is where a lot of the air quality sensors are located in the city of Newcastle. And to a very large extent, it makes sense if you're thinking about sort of ambient population, people moving around in the city, like other people, they're shopping, they're working, but also sort of covering the sources, the emissions. All right. So if we think about managing coverage trade-offs, right? The thing is it's hard. It's hard to do a good job. So this is sort of like if you're on this sort of journey of the project with me, one of the things that happened sort of in the middle of the project was that it was really easy, especially after the first paper, to just be super critical of the city of Newcastle and the Urban Observatory. But also just to sort of, if you internalize this idea of sort of inequity and that decision makers are making biased decisions, it kind of puts you in a corner because what do you do? And I think it's just really, really hard to make good decisions. Like if you're the person who's responsible for deciding where to put air quality sensors in a city, what are you going to do? Right? You've got a fixed number of sensors. You don't have an unlimited budget. They also require maintenance. They get broken. Like it's not like a one-time cost. You're investing in something that you're going to have to think about from here on out. Do you maximize coverage of sources? Do you think about exposure? How do you balance those two things? How do you think about sensor quality versus quantity? All right. The really high quality sensors, they're going to be really, really expensive. And they're not going to, it's not like their coverage footprint is going to expand a lot, right? So you've got this trade-off that you're trying to make between getting estimates of air quality that you think are pretty decent versus coverage of the entire city. Do you place your sensors so that you can say something about what kinds of people are covered, or are you placing your sensors so that your model, you're hoping for sort of a better performing model? And how do you know which groups to prioritize? Do you think about kids? Do you think about health? Do you think about older populations? And each one of those is going to come with trade-offs. So I don't know. Actually, since I can't see who's here today, I have no idea. But I think that I would feel pretty anxious about trying to make a good decision in this situation, right? It's just really hard to get it right. Okay, so what we're doing for this piece of the analysis is asking whether or not we can identify compromise networks. So we're not going to maximize coverage of any one subgroup, but we're just going to try to do okay for everyone, acknowledging that there are going to be these trade-offs. Okay, and so here, when you do this multi-objective optimization, what you do is you don't get like one network. In our case, we generate like 200 networks that do the best they can across all of the groups that we're looking at. And we look at the total population, children, the older population, and the workplace population. And it'd be really nice to look at other kinds of vulnerability. It's just that as in the US, it's really hard to get those data, whereas census data we have access to. And so children and older populations are standing in as a proxy for other kinds of vulnerabilities. So we generate these 200 networks for all of these groups, and then you can sort of pick and choose across coverage. So for this network, for example, we've got 55 sensors. Our coverage is at 0.5 kilometer, and we're at we cover about half of all of the groups. Half of the total population is covered, half the workplace population, half of kids, and half of the elderly, right? And so this is just one of the 200 networks. But what you'll notice, if you can sort of go back in your mind to the Urban Observatory and Newcastle and like the state of play, like where sensors, the actually existing sensor network, this is much more uniformly distributed across space. So I think I would probably make an argument that a network like this is easier if you are a member of city council, you're in a planning department, to say, look, we're doing our best to ensure that every part of the city is covered. And there are other cities that have taken approaches like this without algorithms, who have simply said, we start with every neighborhood getting a sensor, and then we move on from there and decide where else to place them. But like they force the equity into the decision around sensor placement. So that's another way that this could be handled. And so these networks are just sort of showing the trade-offs that you get between those two extremes of the older population and the working population. So in the top left, for this sensor network, we can cover about 40% of the older population, but we get close to 80% of the workplace population. So as soon as you choose to prioritize workers, you lose coverage of the older population compared to down in the bottom right-hand corner where we get close to our maximum for the older population, which was only about half of the over 65 population, but that drives that workplace population coverage down to about 40%. So you can't have it all, right? So this is like the easiest comparison to make, that like you've got this obvious trade-off. It's either or. You can't really do both for a fixed number of sensors. Okay, so just quickly looking at how our approach compared to the sort of the Urban Observatories network. This is the Urban Observatories network. So it was 146 sensors at the time when we were doing this part of the analysis in 55 output areas and pretty clustered. Where you see that really big cluster is city center. And then interestingly enough for Newcastle, if you sort of follow the map straight up, you'll see that there's another cluster sort of immediately north. That thoroughfare is the Great North Road. So it's a thousand year old road. But that's actually a very well-to-do neighborhood that has that cluster of sensors. So maybe this piece isn't very exciting, but it turns out that if you have the wherewithal to complain loudly, you're more likely to get air quality sensors. But the thing that was also interesting was that you have a very well-to-do neighborhood juxtaposed with a very large thoroughfare that is producing lots of emissions. So you sort of get this sort of unusualness of having upper middle class people living with dirty air, but who are able to make their voices heard and make sure that they're getting coverage. But then you can see sort of down along the river, a lot of these are poorer neighborhoods, more deprived neighborhoods, and a lot of them don't have any sensors whatsoever, as we saw with that map with the index of multiple deprivation. So on these maps for the different groups that we're looking at, the orange areas are areas that are sort of underserved by the existing network. So there's a lot of orange for the total population, a lot of orange for kids and residents over 65. The purple areas are sort of over-covered, right? So this is where there are just multiple air quality sensors in one location. So the city center is a really good case where you could argue that maybe you could de-densify a part of that network and just shift it to other parts of the city and have a more balanced coverage of the entire city and of different groups of people in the city. And so this graph is showing like all 200 networks that we make. The black line is showing the Urban Observatory's performance for these different groups. And so I forget what the proportion was of our networks, but it was a really large share of those 200 networks that we generated that performed better than the Urban Observatory. So there were lots and lots and lots of choices in parallel universes that could have been made about where to put the sensors that would have been better than what actually ended up happening. And you can see that all 200 of our networks do better for the older population, the younger population, or the total population. If our networks are performing worse, they're performing worse on that coverage of workers, and that's because so many of the Urban Observatory's sensors are in city center, right? And we sort of force our sensors outside of city center. Okay, so now thinking about supporting decision making, this is sort of like the last big chunk of the project that we worked on. And it happened at the same time that we were sort of working on the algorithms and how to think about maximizing coverage. There was one of the postdocs worked a lot in interviewing and talking to local authorities, so local city government, about how they were making decisions about where to place sensors. And so as we were sort of thinking about how to conceptualize coverage, how to measure it, we were also thinking about how we would support decision making. And so this was kind of interesting to us because a lot of the things that we had assumed were going to be important about decision making turned out not to be super important. But what we wanted were tools that might be able to help decision makers create networks that are better, right? Not best, if we could satisfy us, just do a little bit better than we seem to do without any help, right? So that all people and places are benefiting. And so this was a prototype of the decision support tool. This is also in a paper that came out, I think, last year in Geographical Journal. I'll talk about this a little bit in my conclusions. There is something interesting that happens when you work on one project for a really long time. And one of them is that you forget sort of what papers came out of the project and whether or not they're published. But this was the prototype for the air quality sensor tool. And so this is what the interface looked like, where you could choose the number of sensors that you wanted to place. You could choose sort of what that coverage, that theta, and in the end, we just went with theta rather than calling it something like coverage. And there's some sort of help text that sort of helps to explain what it is that why you might choose 100 meters versus 500 meters, for example. And then objectives for like what categories of people you want to maximize coverage for. And so when we originally developed this, we wanted to have more about types of sensors or total budget that is available to spend, because those things seem pretty obviously important to me. Like you might know in your budget for your city how much money you can spend on the air quality sensors. And so that's the one of the biggest trade-offs or one of the biggest constraints you're already facing is that you just don't have a lot of money. What is the best place? What are the best sets of places to put your sensors given how much money you have to spend? But it turned out that that was not super helpful information for the decision makers to have. And so when you input your query, what you get is a graph and a map. And the graph shows you sort of like what coverage looks like, in this case for total population. And you can click on each one of these dots because each dot is a different network. And the map will change and show you sort of like what changes about where sensors are placed. And then you can sort of look at for your selected network how coverage compares across different groups. And then I think in the final iteration, the thing that was also really interesting and important to me was that you should be able to grab a sensor and move it around and then see how coverage is changing. And the way that we thought about this tool was less about like, here's something you should use before you decide to place any air quality sensors, and more sort of a communication tool to help decision makers understand the way the sort of sorting of groups across space works, how trade-offs are working, but then to also help them get out there and explain to people and help engage with residents about where sensors should be placed and sort of the inevitability of the trade-offs that, you know, if you really, really, really want a sensor here, it might mean that there can't be a sensor somewhere else. So sort of increasing the transparency of decision making to me seems like a really good goal to have. Okay, so wrapping up. Yeah, I think it's a really important thing. And I think there are lessons to be learned here. You know, as smart cities sort of sunset and we don't really talk about smart cities anymore, the infrastructures to a large extent are here to stay. And definitely the sort of the idea of cities and technical apparatuses is also here to stay. Right now we talk about AI, right? But the premise holds that I think at the beginning it's really important to ask, like, what is the purpose? Like, why are we actually doing this thing that we're going to do? And what do we think it might look like if it were equitable? So it's a little bit different from saying, how do we make this fair and equitable, and more like, what would it look like? Well, if we thought coverage were equitable, what might that look like? And one size might not fit all, right? Different cities should do things differently, and some places may prioritize one group over another. Demographic composition varies from place to place. But we think there's a really important role for optimization tools, but also the decision support, just to help work through the trade-offs and the communication, making decision-making more transparent. I think there's both a practical and an academic need for clarity around sensor purpose, surveillance, and bias. There have been lots and lots of people in talks that I've given who are just sure that we shouldn't have any sensors whatsoever. And I think we do need sensors. I think we need to be measuring the urban environment, whether it's heat or waterfall, rainfall, or air quality. So how do we do this in a way that communicates how it might be different from other kinds of sensor networks? How do we sort of bring that into conversations about surveillance and bias? A thing that we don't do is that we don't incorporate mobility or sort of time-space trajectories at all, right? So if you're really thinking about exposure to poor air quality, what you really want to know is who's moving around the city and when, so that you can interface that with air quality measures. And so that speaks to the need for air quality measures that are spatiotemporally sophisticated enough, but also mobility data that is sophisticated enough. And I would say our existing mobility data infrastructure is for a variety of reasons, I think, not fit for purpose. And I'm happy to talk about that, but that would be sort of like what we would actually want, I think, to be able to have more realistic estimates, both of exposure, which was when I started, this is what I was really thinking about. So for exposure to poor air quality, but also to understanding what coverage really is for sensor networks. And this was a huge team effort. So I've already mentioned how long the project lasted, but it had a research software engineer at Newcastle, two different postdocs. So Kate Robinson was a postdoc on this project. She's now at Bristol. Iman Zeid was a postdoc on this project. She's on a different project now at Newcastle. And then we had a research data scientist at the Turing Institute. So lots of different kinds of enemy. So lots of different kinds of expertise feeding into the project, which I think is necessary, but also is what made it, I think, especially intellectually stimulating. Yeah, so some final thoughts. Yeah, the multidisciplinarity piece that I just mentioned about the team was key. The sort of, I mean, for example, when I wrote the proposal, was not going to go talk to anyone. No decision makers. I'm not a person who talks to people really. But Iman, one of the postdocs, was like, I think we should go talk to people. And she was right. She wasn't wrong. But she was like, and I'm very comfortable talking to people. Similarly, the software engineer was very used to running workshops on sort of testing prototypes. So for her, it was not such a stretch. Like she knew what we were going to need to do in order to get feedback on what we were doing. And for me, I just don't have that kind of expertise at all. As I've already said, the sort of lengthy project, it does allow you to sort of settle in and think things through. I'm not grateful to the pandemic, but the pandemic did help in this case. It really slowed things down and forced us to think about what we were doing and just allowed us to spend more time on an interesting topic. I continue to be kind of interested in this sort of data equity interface. I don't think I have any answers, but I think we should keep talking about it. And I think, maybe we can't reach perfect, but if we can reach good enough and be talking about and talk about like that process of getting to good enough and what remains in the gaps, I think that that's just really useful also for people who are not used to thinking about data and how data collection works, that it's really easy to just assume that it's all about bias when really it can be about a lot of other things. And this could be lots of decision makers doing the very best they can. And this is what the best they can looks like. And for me, the air quality sensors, because when we talk about like data or data science, people say, well, what kind of data do you work with? And on this project, I'd be like, well, we don't really have any data. Our problem is like where the sensor was placed in the first place. It was about the geographical decision of like where to decide to collect the data. And we don't talk about that very much at all. And I think it's a really important conversation to be having. Yeah, I think it's really easy for inequities to get hardwired into infrastructures. I was having an argument on a different project last week about using air quality data for the UK, all based on sensors. And I was like, oh, I don't know. I'm pretty uncomfortable with Newcastle. And if you scale that to the whole country, I don't know how comfortable I am at using estimates of air quality for the country, all based on air quality sensors. And I think this sort of thinking about inequities from a spatial perspective, I think is a really important lens. New infrastructures, same old challenges. Yeah, and then this sort of bit of like trying to cross the research and policy divide of actually trying to maybe move the needle a little bit on doing better when it comes to a core piece of infrastructure for cities. And that's it. So I think what I'll do is I'll stop sharing. Hopefully there are still people here.
Thank you. And thank you. I'm Jenna. I'm one of the co-organizers of the working group. I'm happy to kind of help moderate with some of the questions, although I'll just flag we have quite a few questions in the chat, so maybe one course of action is to go just sort of through those.
Okay, so yeah, first one, does this kind of air quality sensor data validate the idea that equity-seeking areas tend to already have poor air quality as an effective cost of housing? So a question is this like an environmental justice question that like basically we know there's an intersection between the kinds of people and the kinds of disamenities? Is that what the question is? I don't know if this person's still here.
I think if you're here, feel free to go off mute.
I just don't want to
clarify.
like.
Yes, sorry. Audio is disabled. Give me a minute to enable it.
Oh yeah, sorry. I think yeah. There's someone is still here, so they can ask the question. Maybe while Sandra's figuring out for Bogart, Felipe, you have a question also there. Then maybe you can jump in and be first in line since you already have audio privileges.
Yeah, of course, it's slightly unfair because I was co-host before, so I get to ask, but I'll just go in. Thanks, Rachel, for the talk. Really interesting slides and projects. I guess my question is about how are the decisions for things like sensor placing made in terms of how centralized they are, right? I wonder that usually there might be some form of delegation from like a state government to like an environmental agency. I'm not super familiar with this topic, so I'm curious. So like what's the level of coordination that these decisions need? And whether, for example, residents have some decision power. I don't know if these things are like put to vote or to discussion. I'd love to hear more on that.
Yeah. So big caveat that I suspect this varies from country to country and city to city and probably even sort of neighborhood to neighborhood. But I can give some observations about the Newcastle case and sort of having given this kind of talk several times. So what's fairly common across countries is that there are mandates that come out at sort of state or national level that say you need to be monitoring your air quality, and often it's because a place has breached air quality, right? So they're being monitored. They then have a choice how they make sure that they provide those measurements in order to ensure that they're within the required bounds for different air pollutants. And so then cities will decide where to place sensors. You can't just go put a sensor wherever you want. So I think this is probably true pretty much everywhere. So in the Newcastle case, they were really constrained in terms of like who owned street furniture and who would allow them to place air quality sensors. So if you don't have enough sort of street furniture, like lamp posts, for example, that you own, then you're not going to be able to necessarily put an air quality sensor in that location, even though you really know that there should be one there. And this speaks to the some of these neighborhoods in Newcastle not having sensors. I mean, what the Urban Observatory told us was like that neighborhood, it had a really nice air quality sensor, but after it got destroyed the third time by people throwing stuff at it, we decided not to replace it because we couldn't afford to replace it. And so there is a thing about some kinds of areas, if the infrastructure is destroyed, it just doesn't get replaced. And then about who gets a say in terms of where the sensors are placed. In Newcastle, there's sort of two tracks, and I think this is also not uncommon. There's the sort of top-down decision about where to place sensors given the locations that you can place them, and then there's a sort of like citizen science, bottom-up approach to requesting to have a sensor, and so in Newcastle, this is called like sensor streets, I think is what it was called. And so you could make a request to have an air quality sensor and you would have it for a set of months. And then often there would be like local citizens groups for the neighborhood that would manage those data streams. And that is a way to sort of ensure that residents have a voice. But I will not be the first person to point out that it's very particular groups of people who complete that paperwork, who know that they have the right to ask for a sensor and who then have the expertise to handle like monitoring the data and taking care of the sensor. And the same would hold. So a lot of the schools had an option also in Newcastle to request air quality sensors. And it was the same thing. It was a lot of schools and sort of the middle class neighborhoods. So you end up with a sort of like, extra coverage in places for people who know how to ask for it. I am a fan. I'm trying to think like of examples. So London had a sensor project at one point. The other thing is that a lot of these cities, they have lots of different people, lots of different actors who are dealing with this infrastructure. So sometimes it's the city, sometimes it's industry, sometimes it's a research project, and sometimes they're all kind of working together. But there are examples, and I think London is one of them, where there are a certain number of sensors that are going to be placed. And the first thing that happens is that one goes in every ward. And once every ward has a sensor, then you can think about where the additional sensors can go so that you're also sort of imposing some equity into the system.
That sounds great. Thank you so much. Yeah, that's super, super interesting. Thanks.
Great. Okay, Gabriel put an order in the chat, so B. Bogart, feel free.
Hi, can you hear me?
Yes.
Okay, I had to change my Bluetooth settings. Anyway, with the time left, I'm just going to jump to my second question because I
Okay.
think it's more relevant. And the second question was about racial data, poverty, unhoused folks, which are
Yeah.
obviously most exposed, most at risk. And so I see you have workers, which could connect to some of that, and elderly folks and children, but I don't see any of that other data. So how does that intersect or not with what you're doing, or is it an access issue? You don't get access to that kind of data?
Yeah, so no, well, yeah, it's partly an access issue. So when we did the worker population, it wasn't because we thought workers were particularly vulnerable, it's because same as the United States, like census data are like basically where people are sleeping at night, right? It's not where they necessarily are during the day, unless they're older population, right? Kids go to school, workers used to go to work. And now I think it's all muddy. Now we don't know where anyone really is during the day, right? But up until 2020, that was sort of the assumption. And so the worker population was just an attempt to try and get it like during the day. What kind of coverage do we think we're getting for some population? So what you really want is mobility. Um, you want to know where people are and then look at where sensors are placed. But in the UK, ethnicity, so they don't, race isn't a construct that is as much of a thing, but ethnicity is a thing, but doesn't work the same. It's not as important as it is in the United States. So it is not the first variable. And I think it's harder for us because we didn't have access to health vulnerability, which I think is really the key. We decided that the best proxy is probably the older population and the younger population because we know that kids and older populations are very vulnerable to poor air quality. Whereas with ethnicity, it's a little bit more of a leap to say that you think some groups as an entire group are all more vulnerable. And again, I think this speaks to the sort of local and national context that this kind of work takes place in. This was in the UK. If I were in the United States, and I think it would be even if I didn't think that race was salient, we would still look at race because that's what we do, right? Yeah, and poverty, so we have the index of multiple deprivation is great, and we don't have something comparable in the US. We didn't incorporate that into the optimization framework because it was a little bit harder to actually get at actual people because IMD is a neighborhood. It's for neighborhoods and not for numbers of individuals who are exposed. And so it just seems, yeah, not as clean to do that. But I think it is important. I think the thing to do is, so in this sort of, you know, proof of concept for the decision support tool was like, what data do we have off the shelf that we can use? But if you were a city and you really care about these things, what you want for your city is to think about what dimensions are going to be really key for the inequities and then trying to measure them. Yeah, I think that's really important.
Yeah, thank you. I think Elijah has a question, but he said he can't unmute right now and said that I have a free pass to budget his question and also add on a little bit. He asked it in the chat. Second question was about the infrastructure and whether we can factor that in some sort of algorithm for sensor placement, especially in the case of air quality. There are maybe clear or some clear notion of who's the culprit and who's to be measured there and what neighborhoods should have more accurately and timely sensor. Like he mentioned the case of if a power plant in the city would produce worse air quality, could you use this information to just guide the allocation? I made a comment about spatial correlation imposed by highways, and highways are widely studied on the context of air quality, but they cross in a linear fashion, especially truck routes don't have many exits, right? So you would imagine that placing sensors adjacent could be different. So how can we factor those infrastructure things in? And is there a different theoretical embasement for that, or does this fit into the framework?
Yeah, no, it totally fits. So as the project was winding down and everyone was having to move on to other stuff and get other jobs, the piece that didn't get done was that, yeah, there's no reason in the optimization framework that you couldn't be trying to balance. So we end up focusing on the exposure piece on the vulnerability side, but you could just as easily have inputs that are sort of maximizing coverage of source, right? Like where is the pollution being produced? And you've got these trade-offs between making sure that you've got coverage of source versus population. We just ran out of time. We did a little bit on like road networks and sort of density of road network and like estimates of like, if you know how busy the road is, like what do we think is happening in terms of emissions? It's a little bit trickier. But yes, it is a thing that would definitely be a really useful additional perspective. Oh, and so yeah, and so yeah, we chose the centroid of the neighborhood because we didn't have access to any other like you need a point. Like you need a point where you can place the sensors. And we had started thinking that we might just do lampposts. Like if we could just get all the lampposts in the city, then maybe we could just use those. But then, it turns out that you can't use all of those lampposts. Like just from a regulatory standpoint or like an ownership, it was super complicated. And so the centroid for us at least, like it's not obviously not ideal. Like the centroid is going to be somewhere that is not practical, but it allows you to get started because we lost a lot of time, like several months at the beginning, trying to think about like what would we use to sort of anchor sensors across the landscape. But yeah, so it's definitely not ideal to choose just a centroid.
This is really great. I'm just gonna flag, we only have a few more minutes. So if anyone, like last question, if anyone wants to ask a question, please feel free or put in the chat or raise your hand. And if not, I have a question.
Do it.
Okay, I'm not seeing anything. Yeah, so I guess I'm curious. This is a little bit of a selfish question related to some work I've been doing on comparing indices for vulnerability assessment and hazard vulnerability, kind of, I think, somewhat related to the multiple deprivation index you mentioned versus other kinds of ways of making decisions in government around like allocating resources or sort of placing infrastructure objects like a sensor. And so I guess I'm curious if you at all, like if that's kind of tension between an index, which is sort of made from these different like socio-demographic types of information, if that kind of like if you looked at that or like tested the flexibility or the assumptions around some of these like indices like the multiple deprivation index and how that relates to decisions around placing placing sensors in more vulnerable areas.
So you're asking sort of like how we measure the characteristics of people. Yeah. I mean, if I were going to make like a final plug, it would be like I think we underestimate how important it is to actually think about what the characteristics are of individuals that we need to be measuring and how we're going to measure them. Right? I mean, like my soapbox right now is the mobility data because we don't actually know the characteristics of the people doing the movement. All of that's coming from like ACS or census in the US context. We actually need to know this information. And we need to, in the same way that you have to conceptualize what coverage is, I think you have to conceptualize what vulnerability is, right? And so there are these dimensions that we know are really important, like asthma, right? And if we could just have like counts of numbers of people with asthma, but it turns out that violates a lot of privacy rules. But that's kind of what we need to get at. And I think it's complicated because we need both to spend time conceptualizing what it is that we need to be measuring, and then we have to figure out how to go out and actually measure it. And if you're working in a city, you're actually kind of hoping that you've got it for everyone. Like you don't really want to sample. You kind of want to know where like all of the unhoused people are, for example, right? Yeah, so it's not a full answer to you, but it is like, yeah, I think it's a really, we don't spend enough time thinking about like how we're going to measure vulnerability and what it actually means.
Super helpful. Gabriel, did you want to try to ask your question? I mean, we are at 1 p.m.
Yeah, well, these Frankenstein says, I mean, I think these sensor networks, I mean, in 10 years, I'm not sure we're going to care at all. I mean, my sense is that we're going to move on. But
yeah, I feel like especially the idea of data circulation being potentially different among different sensors in the network is interesting to me. As you mentioned, like, industry collaborators come along. Sometimes along a long project, you may get a new collaboration later on, and then they're like, yes, we're good, but we want the new sensors to have those connotations. And then I wonder how that can, factor in some optimization where you have to worry about sensor-specific covariates about like, yes, the sensor is going to help, but also it's not a good,
yeah.
Interesting
I
to
mean,
think about, I guess.
right now I'm a little bit all in on Earth observation. Like I just kind of think that we're going to be able to get there, and that like treating this as point based. Some of these data, they're not point based. Like why you would think that air quality should be measured at a point and that then you were going to know something about the entire city. I don't know if you follow like this whole Paris airport, like the bedding market and the air temperature at the airport. Like one sensor for like how warm it is in a city is just like a really bad way of doing things, but it was the best that we had. I think that we're going to be able to do better. So it's also just been nice to sort of be in the middle, or interesting actually, to be in the middle of technological change and observe that like what is state of the art now probably won't be state of the art in a couple of years. And we can ask more of our data.
Awesome.
Thank you for having me.
Yeah, I think maybe Philip and Sandra, if you want to do a last plug on the remaining of the series. Otherwise, I guess thank you so much, Rachel, for agreeing to come. I hope this was helpful to everyone else as it was to me. Yeah, I guess.
Thank you so much. Thank you so much, Rachel. Thank you, everybody, for joining. We're looking forward to having you in the next sessions, May 14 and May 28th. They're all in the website. Again, thank you so much to Gabriel, Jenna, and Matthew for hosting this colloquium series, and for Rachel for giving this wonderful talk. Thank you so much. It was really great.
Thank you for having me.
Bye. Have a good day, everyone.